one tangent property. For each of the following circles, draw a right angle from the point of tangency through the circle. I'm just going to tilt mine so my tangent's at the top. So I'm going to put my ruler so the edge is flat against that tangent. No measuring, we're just drawing a right angle. So I showed you on Friday how to use the bottom edge of your ruler to get a right angle. So just putting my bottom edge of the ruler to make the right angle. What do you notice about that line I just drew? All lines are straight. Squiggly line's a curve. What do you notice about that line that I just drew? High five! What point did it happen to go through? The middle. What do we call a line that goes through the middle? I'm going to do the same thing with the second one. Again, just rotating it so that I can put the bottom of the ruler against it. What do you notice about the second diagram? It's another radius. What do you think might happen with the third diagram? I'm going to put in that little right angle symbol because that's the heart of this property. Wherever the tangent hits the circle, we know is called the point of tangency. The one radius that's formed always forms a right angle. So the property says the tangent to a circle is perpendicular. The tangent to a circle is perpendicular to the radius of that circle. Kind of similar to the chord property. Of course, it doesn't cut the tangent in half because tangents go on forever. Just happens to form a right angle. So let's look at some typical questions. Again, not drawn to scale. The point on the test, the quiz, whatever, is not to grab a ruler and measure it. That's not going to get you the right answer. It's to use the circle properties. So the circle O is the center. RS is tangent to the circle at Q. What do we call Q? Point of tangency. We want the measure of P to O to Q. So just from this property, we know right away that this is a right angle. What do we call the line from O to Q? It's a radius. So I'm just going to highlight so it stands out. Do we have any other radii in this circle? What kind of triangle does that make QOP? Isosceles. Two equal sides are isosceles. What else do isosceles triangles have? Two equal sides and two equal angles. Well, if I know that this is 90 and I've used 48 degrees, how much is that angle inside that triangle? So I know this is 90. I've used 48. I just heard 5 different answers all at the same time. 42 has to be this guy here to make up that 90. If he's 42, what angle is at P? Also 42. I haven't even looked yet what the question wants to ask. I'm just filling in stuff we know from triangles and circles. What is the question asking for? What is P to O to Q? So this guy on the top of this triangle. How do we find him? Yeah, what do we know about the three angles in any triangle? So we know 180 minus 42 minus 42 has to equal the angle that we want. Easiest way to do this in your head is take off the 80 first. So what's 180 minus 80? Then subtract another 4. 96 degrees. questions so far? Okay, let's look at some more tangent ones. Yep. What do you notice about this diagram? Looks similar to the last diagram, so this is a common diagram when you have this kind of triangle. I like to highlight the radii because then it's a little bit easier to see where the isosceles part is. So we know just from definition of a radius that OB has to be the same as OD. What else do I know about the radius and this tangent? Makes a 90-degree angle. That's the property we just talked about. Again, I don't even know what this question's asked yet. I'm just filling this in from what we know. What is the question given us? And where is DBC on this diagram? The bottom one. What are we trying to find? Turn and talk with your partner. Figure out what the X is. Way to look around there, Brody. Way to look around. Sorry? Yeah, because that's the property. If this is 90 and we've already used 37, how much do we have left inside the triangle? Offer of 53. What else do we know is 53? A little more specific because there's a bunch of other things in this triangle. Angle D. Why? Why does it also have to be 53? Isosceles. I'm going to ask everyone to take their earphones out, please. We never have those in when I'm talking. How do we find X if we've got 53 and 53? Add them together gives us? And then we're going to minus from 180. Offer of 74. Not degrees Celsius. Do you see the similarity between 1 and 2? Do you see the similarity between 1 and 2? Let's look at a second typical diagram. This funky one here where the triangle goes jutting right outside the circle. What do we know before you even read the question? Just from the diagram, what do we know? O to M is a radius. Is there another radius? What else do we know? O to P is equal to O to M. I think I marked that already. Yeah, what else do we know? What's the property from today? Yeah, so the tangent is actually this line here. They just didn't draw the other side of it. But if you need to do that for your brain to understand as a tangent, then draw it. They just didn't draw the right or left-hand side because they didn't need to for this diagram.
How long do you need to add on to the other side?
Whatever. So what's the angle in here at M? Has to be a 90-degree angle. Okay, so without even looking at the question, without even getting the numbers, we know those things already. Now let's add on what do we know from the question. MN is 15. Yeah, what kind of triangle is this? It's a right triangle. What do you know about 3 sides in a right angle triangle? What would you like to call A? B? Now I can't directly find x, so I'm just going to leave this and call it C. It'll be the length of O to N, but we'll figure out x in the next step. Bed mass, what do we do first? Brackets, no brackets. After the brackets, exponents. Offer of 225. I heard a really quiet 17 from the corner. Just looking for confirmation. 17. So what did we find that's 17?
The whole thing from O to N. Now you have to subtract by it. Or subtract 8.
So what does our x have to equal?
9.
Questions? Try number 4 with a partner. I just wrote down the information from the question. What do we want to find? How are we going to find it?
8 all squared plus 40 squared equals, we use x instead of saying c.
You can use whatever you want. Where did the 40 come from? I have no 40 on my diagram.
9 plus 11.
So the whole length E to C would be the sum of both.
So it's 144 plus 1600 equals x squared.
17.4.
1744.
Oh, that's not the point. That's x squared.
Yeah, it's
Ooh, my white went all gooey.
17,000 or 1,744.
We're good, 1744.
41.8 centimeters.
Offer of 41.8 centimeters. Looking for confirmation. Why do we have units on this one and we didn't on the last one? Because the units are given in the question, so if there's units included, you need to put units on your answer. Do you see how a lot of this is Pythagorean theorem?
What is the last one?
Oh, we're not there yet. We're still on number 4. Don't jump ahead. Try to savor this. This is our last examples. I might make it stretch out all class. I know, this one's getting crazy. Look, there's stuff everywhere. The minute you see a tangent to a circle, what do you know about the tangent and the radius? So that 90's not marked, put it in right away. The other thing I do is I start marking equal radii. Give me some radii in this question.
X to C. Where you see an S? X is it? Oh, X to C. Or O to C. O to the side. Oh, that's an A.
So we actually have a bunch of equal or isosceles triangles in here. If I took away this line right here, this looks like example 1 or 2. So walk me through, what did we do in example 1 or 2? Found the thing. Yeah, found this guy in here. So if this is 90 and we've used 58,
Subtract 58.
heard an offer of 32. Not all of them, but there's one other that's 32. Then what did we do in example 1 and 2?
Add those two together.
Add them together and subtract from 180. So if we add them together, we get 64. Offer of 116, I heard? So just by taking away that line, it's exactly like example 1 or 2. All we're doing is adding in one more line. What do you know about the angle in here at a half circle? Has to equal 180 because it's a straight line. Straight line. If this is 116, how much is over here? Offer of 64 units. It's degrees. How do we know it's degrees? Because we're trying to find an angle. Okay, so exactly like 1 or 2, the only difference is we added one more line. This is it. This is our last example of grade 9 math.
Oh no.
A little sad. Okie dokie. What do you want to do?
Gotta find which one's 90.
Okay. Got to be one somewhere that's 90 because that's the property.
B.
Angle B. Name the radii. Again, you don't have to highlight them. It's just the way my brain works because then I can see that they're going to be the same. What are we trying to find?
Determine the measure of CBF.
Put an X where we're trying to find it and just compare with someone sitting in front, behind, beside you. Put an X where you think the angle is we're trying to find and just compare.
Right there.
Your X should be right there. If I took away the line B to F, this is exactly the same as the one above or 1 or 2. The only difference is I've added in this one extra little line. So let's start the same way we started before. If this is 70, what else is 70? Careful. It's got to be B. Why?
Or EBD.
Yes, why? Because it's the one along the non-highlighted line that has the two angles that are the same, not the one of the two highlighted lines. So not the peak. It's got to be these two. Okay, now what? Okay, we know this is 90. We know this is 70. Offer of 20 for in here. Now I'm going to highlight this shape, which we talked about the very, very first day of this unit. It's the X. It's not a bow tie. It's just the X. X doesn't necessarily have anything to do with circles. What do you know about the opposite angles of an X? So what do you know about angle C to B to F? 20. Again, the only thing different I added was this line B to F. Besides that, it's exactly the same as example 1. All we're using is that X property. Math is over.
Math is done.